Welcome, friends, to another session of What, Why, and How by Stats SD. I hope you've enjoyed my previous videos. This is in the series of statistics where I make it easy for you to understand how to calculate certain statistical measures. These tutorials are specifically for students from maybe BBA, BCom, MBA, or researchers who want to understand the calculations behind these statistical measures. The topic of our discussion today is median. Now, if you have seen my previous videos on mean specifically tells you the average. As I mentioned, average would give you an idea about the central tendency or an arithmetic average of a set of numbers. Then why do we need to study median? I've put up a definition for median for you. Uh, the median is a statistical measure that represents the middle value in a data set when it's ordered from least to greatest. In other words, it is the value separating the higher half from the lower half of a data set. Let's look at an example. I have plotted the number of likes that app 1 2. So I'm comparing 11 apps and the number of likes that each app has received. As I told you, we need to arrange the data set from ascending to descending. So app 1 got 12 likes, whereas app 11 got 22 likes. Now, what does the median tell us? The median tells us that how the data can be divided into two equal parts. Now, a specifically mean might also give you an idea about the middle position, but then why study median? So, if you see, median is the sixth position in this case. How did I calculate sixth position is what we will understand in our next slide. But if you see, the sixth position divides the data set of 11 observations equally into two equal parts. So 1, 2, 3, 4, 5 fall on the left hand side, which is in the lower half, whereas 7, 8, 9, 10, 11 are numbers greater than 6. So equally it divides the data, and the median position, sixth, would have a corresponding value which is 17. Now moving on to the calculation. As I told you, why study median? Assuming I find that the mean for this data set is somewhere around 16 likes. Assume I also add another company, 12th app, and the number of likes increase to 100. That will distort our average, and the average may move to around, say, 40, 45, which may not give you a true picture for the 11 companies. So outliers or extreme observations on the left hand side and right hand side can skew the average or mean. In those cases, when you analyze the data set and you find outliers or extreme observations, the median becomes a good measure of central tendency. So the choice is with the researcher in terms of either using mean or median, but a median of, say, 17 or a mean of 18 are close to each other and it describes the data set. So let's look at how do we calculate median. So we have two methods. One is the ungrouped data and the second one is the group data. As I mentioned, ungrouped data would be your observations which are not in a class interval. So you have discrete numbers, say on the left hand side you have 84, 85, 87, 88, whereas group data would be in the class interval 80 to 85, 85 to 90. Now for ungrouped data we have two formulas. One is median is equal to n plus 1 upon 2. This formula is applicable for odd number of observations in your table, and for even number of observations we have n by 2 observation plus n by 2 plus 1 observation divided by 2. So let's look at the calculation. Let me choose a particular ink color to highlight. Okay, I'll choose blue. So here, okay, for the odd observations, the formula says n plus 2. So here I say equal to, I have 11 observations, 11 plus 1, sorry, maybe I'll rewrite it, 11 plus 1 divided by 2. So it would be 12 divided by 2, which is 6th. Please note, median describes the position. It is a measure of location. So the sixth observation or the sixth position would be here, and the value corresponding to sixth position is 90. So in this case, the median calculated would be 90, though it would be on the sixth position. If I come to even observations, the formula says n by 2. N specifically stands for the number of observations. So if I do n by 2, it comes to the 12 divided by 2 plus n by 2 position, that is 12 divided by 2 was 6 plus 1 upon 2. So when I do n by 2, it should add up to the sixth position, and when I do 6 plus 1, it would be the seventh position divided by 2. Now we are interested in the values in the sixth position. So the values in the sixth position were 90, and the value in the seventh position was 91. I take an average of it, which is say 90.5. I hope it's clear that when you're working with ungrouped data, we have two formulas for odd observations and for the even observation. The median tells you the middle value and the value corresponding to it. Now we're looking at calculations for the group data. So let me proceed. Okay, I'll maybe discard these values and we'll go to the group data. Now in your group data, you have data something like this: quantity 10 to 25, and you've been given frequency 25 to 40, and this would be your frequency for each class interval. If you remember in my previous videos, I mentioned in the class interval 10 to 25, 10 would correspond to the lower limit of the class interval and 25 would correspond to the upper limit. Specifically, if I notice that if this describes quantity, it means that there are 300 items or quantities which correspond. It could be 11, 12, right up to 25. So this is an example of a group data. Now for group data, calculating the median, there is a formula which is prescribed. It's below, which is L plus n by 2 minus CF upon F into H. Let me make it clear what each term means. L means lower limit of the median class. So first thing that we need to identify is which is the median class. So I will come to that. N stands for the number of observations. So number of observations in a group data would be the number of or the total of the frequency. So the frequent number of observations would be 1624. CF stands for cumulative frequency of the class before the median class. F stands for frequency of median class, and H is the width of the median class. So let's calculate. How do we find cumulative frequency? Cumulative frequency is the frequency added to the previous one. So for the first class interval, the frequency for the class before that would be considered 0. So 0 plus 300 would be still 300. 300 plus 467 should be 767. 767 plus 328 should add up to 1095. 1095 plus 123 should add up to 1218. And the last one, 1218 plus 406, should add up to our total frequency. So if you see, these both correspond to each other. If you're calculating cumulative frequency, the last one should add up to your total frequency. Now, how do I identify which is the median class? The formula is simple. To calculate the median class, we take n by 2. In our case, n was 1624 divided by 2. That is, we are interested in the 812th observation. So if you remember, median corresponds to position. We are interested in the 812th position. If you look at the first class, in this we have up to 300 position. So 812th position cannot be accommodated in the first class interval. If I go to the second class, it includes maximum 767. So 812th position cannot be included. If I go to the third class, the maximum number of positions allowed are 1095. Certainly 812 or 812th position would be located. So what I do is I will go ahead and highlight this class interval as my median class. So for your reference, I have already calculated the table which is mentioned here. So if you see here, we have highlighted in yellow the median class interval. Now let's jump into the calculation. So as I write the formula, I will explain again each term. So the formula is median equal to L. L corresponds to the lower limit of the median class. We just identified the median class 40 to 55. So the lower limit is 40 plus n by 2 is 1624 divided by 2 minus cumulative frequency of the class before. So the median class is this. So the cumulative frequency is 1095, but you need to take the cumulative frequency of the previous class for the second class, that is 767, divided by the frequency of the median class. The frequency of the median class is 328. So I divided by 328. And finally, I multiplied with the class width of the median class. So if you notice, for the median class, the lower limit is 40 and the upper limit is 55. So we have class width of 15. So I mention here. Now, some points of note. When you are calculating this, do not take an LCM of 40 plus. So 40 is a separate term which you keep it separate and then you calculate. So 1624 divided by 2 should be 812 minus 767 divided by 328 into 15. If you remember the BODMAS formula, I'll write it for you on the top. What should be your sequence of calculation? Bracket open, division, multiplication, addition, and subtraction. So in our term, first we will do bracket open, then division. So I write 40. We did division 1624 divided by 2. Now, when you have this, now we'll do 812 minus 767, which is 45 divided by 328 into 15. Now, should we do division first or multiplication? The precedence would be for division. So again, I write 40 plus 45 upon 328 should add up to 0.137 into 15. Now we have two more operations, plus and multiplication. So multiplication takes precedence. So I will take 40 plus 0.137 into 15 should add up to 2.05. And your final answer is 42.05. I hope you've understood how to calculate median for a group data. I will just revise again. So when you are given data, first step, calculate the cumulative frequency. So if the frequency mentioned for the first class is 300, add the next frequency 300 plus 467, 767 plus 328, 1095. Then we will identify the formula L plus n by 2 minus Cf upon f into h. L corresponds to the lower limit of the median class. To calculate the median class, we divide n by 2, 1624 divided by 2, that is 812th observation. The 812th observation lies in the third class because the second class can only include 767th position. So 812th would lie here. So I put all these terms in the formula. So lower limit is 40, n by 2 was 812. The CF of the previous class was 767 divided by the frequency of the median class 328 and finally multiplied with the class width, that is 15. So my calculation yielded an answer 42.05. So observations from 10 to 85, 42.05 is the middle value which divides 1624 observations. I hope you have understood how to calculate median for ungrouped data, odd observations, even observations, and finally for group data. This mentions the direct method. There is no indirect method for the group data. If you have liked the tutorial, please click on the thumbs up button and also subscribe to my video